Good evening, everybody, and welcome to a deep dive video. That's right, deep dive. Probably you must have seen the project demo video, and that might have made you interested to do a deep dive video with me. So that's right, this is the video where I'll go step by step approach on the code. What are we doing? Well, we are gonna power our search stack, Elasticsearch from transactional data like Apache Huri using incremental queries and RFC51, that is change data capture, right? Now, first of all, somebody would ask, why would you want to do that? You want to do this because A, your petabyte scale data is on S3, you're saving a lot of cost on storage, and you're only bringing data in the downstream system that is operational data, right? I don't need to bring my petabyte scale data to Elasticsearch, right? I'll be paying a lot of money and I have to add so many nodes. So I'm only bringing data that I need, right? So basically, I'm gonna show you in this video step-by-step guide how to create a transactional data lake, how to capture CDC event, that is insert, update, deletes on transaction data lake, and then bring those events into your Elasticsearch. So let's get started, deep dive video. All right. So probably, as I said, right, you must have seen the, the project demo video, and that is why you are watching this video. So again, the first thing, I'm gonna make things easy for you, okay? So the first thing is we gotta create a transaction data lake, and then we're gonna insert some sample records, and then I'm gonna show you the template part, okay, in a second. All right, so the first thing that I need to do, this is what we're gonna build. Power your downstream Elasticsearch stack from Apache Huri transactional data lake with CDC. All right, so the first thing, I'm gonna define imports. Again, I don't think I need to explain you anything. I'm simply defining imports. Here I need to explain you, so I'm gonna tell you. So I'm using Hudi 0.13, the latest version, because that latest version supports CDC, change data capture. So I'm gonna create a Spark session, and here you can see I have my Spark session created. Now to teach you, I'm gonna name the database as HudiDB. I'm gonna name the table name as Hudi CDC table. This can be employees, order, sales, can be literally anything. Record key is what is unique in what uniquely identifies a row. In my case, there's a column called UUID. That is something that's gonna uniquely identify my data. That's the path of my data lake I'm creating on my computer in the temp folder. Precom key is usually used for dedupe purposes. When you have a batch of incoming records and you want to dedupe, this is perhaps used. Usually people use timestamp or date attribute to do the dedupe. Method type is upsert. I'm going to perform upsert on my transaction data lake, and I'm going to use copy on write. For streaming use case, we recommend using merge on read. But again, based on your use cases, you can either select the version. Now here, again, these are pretty standard settings that I'm using, and the only two things that you got to remember is these two options. Enable CDC, and I'm essentially saying that I'm interested in the before and the after part. Okay, so I'm going to execute the cell. And I'm gonna insert record number 1 and 2. So I'm inserting record into my transaction data lake, right? And what I do anticipate is after this, I should see my transactional data lake created. And I have my Hudi metadata, and once the execution is complete, I'll essentially see some Parquet files, base files, etc., etc., etc. So I'm gonna go step by step and show you the entire process, okay? So the cell execution is complete. I have some base file and the Parquet file. Now let's go to the template part, which means we're gonna bring this data into Elasticsearch. I have my Elasticsearch running locally on my computer. Here you can see Elasticsearch and Kibana. I have a latest version of Elasticsearch that is 8.3.2, and I'm using Kibana over here, as you can see. So make sure your Elasticsearch is currently working. So first of all, I'm just gonna delete all the indexes so I can start off pretty fresh here, okay, with you guys, right? Delete. All right, so I perhaps have deleted all the index and I do not have any index at this point. Perfect. Now let's go to the code part, and I'm gonna walk you over the code shortly. So what the code does is when you run the script for the first time, it's gonna basically grab the begin commit and it's gonna perform incremental query. After performing the incremental query, you will get a Spark data frame. After that, in that Spark data frame for the CDC, you have a before part and the after part, just like Debezium. I'm interested in the after part, right? So I'm gonna get that. I'm gonna flatten out the JSON, and basically then I'm gonna insert into Elasticsearch. Next time when you run, it's gonna store the method. So when the job is done, right, it will store the commit on S3. So next time when you run, it's gonna load the data from that commit, right? Basically, it's gonna load the commit, perform incremental query, and get the next set of data. Okay. So hopefully that made sense. Okay. So couple of things you might have to change. Again, I'll let you know. So first you want to put your bucket name. Again, this is my bucket name. Don't worry about the credentials. I'm going to delete it. So don't worry. So this is your S3 bucket, where your metadata files would be stored. I'm using Elasticsearch version 8.3.2, but I'm using 8.4.2. It works, right? Hoodie version is 0.3. And here you can see I have placeholder for the versions, right? And I'm submitting these packages. Put your access, put your secret key, put the region over here. Put the template needs a database name, needs a table name, and the path where your transaction data lake is created. Creating a Spark session, and I have a class that does all the heavy lifting for you. All it does, it takes a bucket name, takes the table name and the path, and a Spark session. Provide these arguments and you're all set. Then what you need to do is call the read method. So the read method will give you a Spark data frame. Then I check if the Spark data frame is empty. If it is not empty, come inside. So remember, the hoodie will return data in a before and an after part. So I'm grabbing the after part. I'm trying to get the JSON schema. I am reading that as a Spark data frame. I'm flattening out the data. I'm dropping the before and after column. I'm dropping basically all the columns that has the word hoodie, because hoodie will create the metadata, right? So I'm basically dropping those in, right? After dropping, I'm doing .show. And here I'm creating an index, and the way I'm creating index is a year, month, day format. So probably I'll use an underscore notation here. So whatever your hoodie table name is gonna create a date time-based indices. Here is my Elasticsearch username. Here is my Elasticsearch password. I'm running it locally, so I'm not even worried about that. If you have seen this, okay. And then here I'm performing an append operation, and here this is where you can change, right? You can define what is a unique identifier. That way, when the next time the same record comes in, it will simply update. If you don't put this, probably you will have duplicates in your Elasticsearch, okay? So I just wanted to let you know that. So now that we have that, I'm gonna run the Python template over here. My anticipation over here is I should be seeing the record number. Where did it go? Record number 1 and 2 should be printed, and it shall be ingested on my Elasticsearch. So I'm simply gonna wait at this point for this to complete. Okay, so looks like it did run. Here you can see it was able to figure out these two records were inserted into the Apache Hoodie transaction data lake 1 and 2, and then now it has inserted into Elasticsearch. If I go to Elasticsearch and I do a cat indices, and here you can see I do see my time-based indices created. So I'm gonna basically query my time-based indices now. Here you can see we have the records coming in here, right? So now what I want to show you is a metadata file on S3 would be created, right? As you can see with the table name. If I download this, and I want to show you. So in this file, it will store the metadata, the last commit, what he has processed. So if you observe last process commit, the table name, when did it, the path, right? The inserted time, when was it processed, right? So it has all the metadata. If I run this template again, I do not have any data because I've already processed this record, so I shouldn't see anything on the screen. So let's run the template again. At this point, I should not see any data points because as I explained you, right, I have already processed the record number 1. That's the power of incremental queries. So observe, it did load the metadata from S3. It is now performing incremental queries, and I don't have any data. So basically, you basically didn't print anything. Now let's flip the scenario and let's insert more data. I'm updating record number 1 and I'm inserting record number 3. Now again, my anticipation is when I go to my Elasticsearch, I don't want to see record number 1 2 times. It should basically perform an upsert on Elasticsearch. So I'm again inserting record number 1 and record number 3 into my Hoodie transactional data lake. I'm executing the cell, and this can take up to about a second or two. After this, when I run my template, I should see only the new records, that is 1 and 3, since I have the last commit stored on S3. So it's gonna perform an incremental query. So again, I'm waiting for the cell to complete. Okay, the cell is complete. Now when I execute this Python template again, my anticipation here is basically it's gonna fetch the last commit from S3, it's gonna perform an incremental query, and it's gonna then load the data into my Elasticsearch or the search application. So let's wait for the code to complete, and here you can see it has basically fetched the metadata from S3, and now it's about to do the incremental query. So I should see the data frame on my console shortly. And there you can see record number 1, which is an update, and record number 3, which is an insert. Now back to my Kibana dashboards, and I'm gonna query the same index. Here you can see, we have an update, that record got updated, and here you can see we have a insert 3. This way, you have successfully now processed the data from your transaction data lake incrementally with chain data capture and performing upsert on your Elasticsearch. And now you're powering your search application now. So that's it for the video. The entire code is on my GitHub. If you believe I've done a good job, please make sure to hit the like, subscribe, and comment on the video that you liked it. Thank you so much, and I'll see you in the next video. Keep smiling, keep programming, and see you in the next video.